Hello students. This video is for lesson 6-15. We are going to be looking at vertex form of a quadratic and looking at the different parts. You can see here on my Desmo screen I have set up some different representations here of a quadratic equation. So in this part here, y equals x minus h squared. You can see I have a slider for h, so we're going to look at how changing the h value will impact our graph. In fact, I'm going to turn these others off, so we just have that red one up there. We will do the same thing with this plus k at the end to explore how changing that k value impacts our graph. And then if I multiply by a coefficient, a, if I change that a, how will that impact my graph? So let's take a look here. First, I want to review the idea of vertex form. So before we begin, I want to remind you of all of our vertex form. So we have y equals, what we've seen before is x minus h squared plus k. And our vertex, that maximum or minimum point, is at the ordered pair hk. So for example, right here, what is that point? And we can see that is at 1, 0. And that is because our h value equals 1. What happens if we change that h value? So here's where I'm going to delete. We're going to slide this over. What's happening? So let's make h 2. So when I come over here, that vertex becomes 2, 0. Interesting. Let's take a look at what happens if we make it 0. Well, now my vertex is at 0, 0. What if it's a negative number? Let's say it's negative 3. Then when I come here, my vertex is at negative 3, 0. Interesting. Well, let's take a look now at what happens if we change the k value. So here we're at that negative 1. So I'm going to come back. I'm going to put this at 1 because that's what we had before. Okay. So let's compare these two right now. The red graph is that original with my h1, so x minus 1 squared. And the blue one is when I have that same quantity of x minus 1 squared plus 1. What happens? Well, this blue graph shifted up. And now this point is at 1, 1. So it's at my h value, k value. Okay, what happens if we continue to change that? What happens if we make this 2? Do you see what happened to that blue graph? Well, now my vertex is at 1, 2. What if we make it negative 2? Where is it now? Well, now my vertex is down here at 1, negative 2. But as I slide that k value, my graph slides vertically, either down or up, depending on what my k value is. For positive values of k, as we increase, that graph will slide up. As we decrease, that graph will slide down. Well, what happens if we change that coefficient in front? Remember, if I don't have anything typed in My coefficient is 1. So we're multiplying that whole thing by 1. So let's see what happens now if I turn this graph on. Well, now I believe it is on top of that red one. So I'm going to turn the red one off. Let's see what happens as I change my A value. And you know what? I'm going to turn off the blue one and turn that red one back on so we can see. Okay. Oh, look at that. If my A value is negative, what happens? My graph flips and it opens down. If my A value is positive and it's a fraction, it's a very wide parabola. And as A increases, my parabola gets steeper and steeper compared to the red one. Okay, so that A value will widen or narrow my graph. It can also change the direction. If my A value is negative, it's going to cause that parabola to open downward or to create a hill instead of a valley. Okay? So try something on your own. Go to desmos.com. Type in some values for A. Let's pick something that you can test and see if you can figure out what will happen with this. So let's say I do y equals A times the quantity x minus h squared plus k. All right. What if I change all these numbers? So I'm going to turn this one off and this one off. Let's say A is 1.5, K is negative 2, and H is negative 4. What does that look like as an equation? So if you fill in that H value, that K value, and that A value, will the graph match up? Let's find out. Y equals 1.5 times the quantity x minus negative 4 becomes positive 4 squared minus 2. And the two graphs line up. They are one and the same. Okay, so we can play around with our vertex form and learn a lot about its steepness, how wide or narrow our parabola is. We can very quickly identify if we have a minimum or a maximum for our vertex. Remember, if A is positive, we'll have a minimum value for our vertex, and if A is negative, we'll have a maximum value for our vertex.